Hello, physics, electric field. The problem is the four equal positive charges, each 8.0 microcoulomb, are at the corner of a square of side 9.2 centimeter. What charge should be placed at the center of the square so that all charges are at equilibrium state? So we have charges. So this is a square. So this is one position, two position, three position, this is four position, and this is fifth position. And at this one is a q, 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 and here is a q, and on the fifth is a small q. So these are all positive charges, positive charges, positive charges, positive charges, and this should be negative charges. So all charges on the corners, positive q. So in the center, negative q. So we will find out the forces. Because this is positive, the force will be away from this one, and for this one, so this will be away, this one and this one. So force F1, F2, F3. Force F1, F1 force, which will be KQ square over the length is L. So L square is toward positive x-axis. So the x component and y component. X component is all x component. So KQ square over L square, and y component is 0. Similarly, this one F2 force, which is a KQ square over this distance. This is L square, L square. This is 2L square, and it will be positive 45-degree angle. 45-degree angle. So this will be equal to KQ square over 2L square into cos of 45 degree, and KQ square over 2L square into sine of 45 degree. So if solve this one, so this will be KQ square over 2L square into, this is square root 2 multiplied by and divided by square root 2. This is 2. So this will be equal to square root 2 KQ square, 2 and 2, 4, 4L square. So this is same, this is same. So this will be KQ square KQ square over 4L square into square root 2, and also this one square root 2 KQ square over 4L square. 4L square. So this is F2, and similarly F3 is up, KQ square over L square. This is going y-axis, so this is x-axis, x contribution is 0, and y component is a KQ square over L square. this one. And last one, F5. F5, it is K, small q, capital Q over the distance. Distance is this one. For this one is half. So this is the distance x. This distance is L by 2. This is also L by 2. So x square is equal to L by 2 whole square plus L by 2 whole square. So this is equal to 2 L, L square by 4. So this is equal to L square by 2. So this is equal to L square by 2. And it is at angle negative. It is will be downward because it's a negative. So negative 45 degree. So it have x k q q o into L square into this 2 into cos of minus 45, and similarly 2 k q q over L square and to sine of minus 45. Both x and y are negative, so this will be we'll solve this one. 2 k q q over L square into with negative sign square root 2 square root 2 square root 2 rationalize. So this is 2, this 2 cancel, so this is equal to minus square root 2 k q q over L square. So that means this also will be this one. So minus square root 2 k q q over L square. So we have this component. So now we will add all these components. So fx is equal to this component kq square over L square plus this component plus the square root 2 kq square over 4L square plus this component minus square root 2 kq over L square. So if we solve this one, and then it will, we have to find the value of small q. So this should be equal to 0. So if it is 0, then we add them together, so that in here, in these two, kq square over L square common into 1 plus square root 2 by 4 is equal to, this will go on other side, is equal to square root 2 kq over L square. L square cancel, k cancel. So small q is equal to, so we have left with square root 2 q is equal to q square into 1 plus square root 2 by 4. So this one cancel by this one. So q is equal to divided by 1 over square root under root 2, 1 plus square root 2 by 4, or it will go underneath. So 1 by square root 2 plus this cancel 1 by 4 into q into q into q, or what we write down, 1 by 4 plus under root 2 q. Okay, so this is the answer. So q is equal to 1 by 1 over square root 2 plus 1 by 4 q. This is negative charge, this is positive charge. So its value q is equal to minus 7.66, so 10 to power minus 4 coulomb. Negative we have put ourselves, so because of the stability. So this is the, so q is equal to 1 over square root 2 plus 1 over 4. This is positive, this small q is negative, so value is this one. So this is unstable equilibrium. Unstable equilibrium because small change in position of q, so large change in forces on the corners. So this is unstable equilibrium. So this is the answer of the question. This is a interesting question. Four positive charges on the corner and one charge should be at the center so that the system should be equilibrium. So the first find the force 1, 2, 3, forces above 1, 2, 3, and then components. F1 component, this one, F2 component, two components, F3 component, this one. So based on their polarity, and F5, which is at the center, and then the force is X component is this one, Y component is this one, both in a negative because it's the downward, like going this direction. So other going this direction and this is going this direction. So fx is equal to 0. There's no need for fy because we have to find the value of the q. So equal to 0. So this will go on the other side. Other side it goes. So then simplifying. When you simplify this one, this will give you the value of the q. So this q positive in the corner is positive, other one is negative, and value, and this. But it is a unstable equilibrium.